Good morning, everybody. So today we are here to discuss about VLAN. So VLAN is nothing but the virtual LAN. I think have you ever wondered how a large company can use the same network switches but still keep the finance department, HR department, CCTV camera, IP phone server, and guest users separate from each other? The answer is very simple. It's VLAN. So VLAN is one of the most important concept in networking, but many beginners find VLAN confusing because they hear terms like VLAN ID, access port, trunk port, 802.1 queue, tagging, and inter VLAN routing. So in this video, I am going to explain VLAN in a very simple and practical way. We will understand what is VLAN, why do we need VLAN, what is the difference between an access port and trunk port, and how VLANs are used in a real world network. So let us go to slide 1 and we'll understand the basic question, why exactly we need VLAN and what exactly is VLAN. So VLAN stands for Virtual Local Area Network. The easiest way to understand a VLAN is to imagine one physical switch. Suppose this is a company network and we have one physical switch. So let us assume that this is a one company and we have one physical switch, but different types of users are and device are connected to it. So in one switch we have different users and different device connected to the switch. So let us take an example. We have administration user, we have normal employees, we have guest users, we have IP phone, we have CCTV camera, we have servers. Now if all these devices are placed in a one single network, everything is mixed together. So instead of we create logical network inside the same physical network. For example, VLAN 10, this we are creating for administration. VLAN 20, we are creating for employees. VLAN 30, we are creating for guest. So we created three different VLAN, 10, 20 and 30. One is for administration, one is for employees and other one is for guest. Now, even if all these devices are connected to the same physical switch, they are logically separated. So let's understand this with a very simple example. Imagine you are staying in a very large apartment building and the building itself is one physical structure, but inside the building there are different flats and you have different flat number, so like 101, 102 and different type of flats. So they all are inside the same building, but each flat has its own unique number and it has got a separate space. So VLAN works in a very simple way and a similar way. So the example what I explained you about the building, so VLAN works in a very similar way. The physical switch is like a building. Assume that the physical switch is like building. The VLAN are like separate flats. So inside the building. So we can have VLAN 10 for administration with networks such as 192.168.10.0/24. So we can create one VLAN ID 20 for user with a network such as 192.168.20.0/24, and VLAN 30 we can create for guest with a network such as 192.168.30.0/24. The most important point in this, we are using the same physical network infrastructure, but we are created a separate logical network. So this gives us better organization, better control and improved security. So if you remember only one thing from this slide, remember like a VLAN is a network created inside a physical network. One physical switch can contain multiple logical network. This is the idea of VLAN. So now we'll go to slide 2. In this slide, uh, why it is basically talking about why do we need VLAN. why not simple connect every device to one large network? So let's take a real world example here also. Imagine you have an office with 500 users sitting in that office. In this office, we have finance department, HR department, IT department, CCTV cameras, IP phone, server, guest users, and blah blah. So now imagine putting every device into one single network. This is called a, let us assume, flat network. So a flat network may work in a very small office, right? But as the network grows, several problems begins to appear. The first problem is the broadcast issue. The broadcast traffic, let us say one computer sends a broadcast message. All devices in the same broadcast domain may receive that message. And one broadcast is not a big problem. Imagine hundreds of thousands of devices are connected and sending broadcast traffic. So what will happen? The complete network will get choked. The network becomes noisy, and VLAN helps us to divide one large broadcast domain into smaller broadcast domain. This is the reason we are creating VLAN. So VLAN help us divide one large broadcast domain into smaller broadcast domain. So for example, VLAN 10 has its own broadcast domain, VLAN 20 has another broadcast domain, VLAN 30 has another broadcast domain. So this reduces the unnecessary broadcast traffic when we create multiple VLAN. The second problem is security. Now imagine a guest user connecting the same network as your finance department. So this is a security risk, right? So when a guest is coming and connecting to your finance department, a guest user should normally have access to internet, but should the guest be allowed to access your finance server? The answer is obviously no. So we create VLAN 10 for internal user, VLAN 30 for guest, because then we can configure a firewall policy like this. For example, guest VLAN internet access allowed and guest VLAN internal server access denied. So see, we are writing two type policy. In one policy we are writing that internet access is allowed for guest, and the second policy we are writing internet server access is denied. So whenever guest comes, they will be able to access the internet, but they cannot access the server. This is very common enterprise network design. The third problem is your network management. Imagine a problem like any problem occurs in your network in a big enterprise. If everything is connected to one network, single network, troubleshooting can become difficult. But with VLAN, we can organize the network. For example, VLAN 10 is for management, VLAN 20 is for data user, VLAN 30 is for voice, VLAN 40 is for CCTV, VLAN 50 is for guest. Now, if there is a problem with IP phone, we know that we should first check the voice VLAN, because all the IP phone is connected to voice VLAN. If there is a problem with CCTV camera, we can investigate CCTV VLAN, because camera is connected to CCTV VLAN. This makes troubleshooting much easier compared to a normal network. So VLAN provide three major benefits. Number one is segmentation, number two is security, and number three is better network management. So it also provides the better network management. The simple idea is, instead of building one huge network where everything is mixed together, we divide the network into smaller logical sections. This makes the network cleaner, safer, and easier to manage. Now we'll go to slide 3, and we are talking here more about the access port, trunk port. So what is the concept? So let us go through the concept. So now we come to one of the most topic like access and trunk. We might have heard in many VLAN concept. So let us understand this. So what is access port? An access port is normally which carries one VLAN. For example, suppose we have a computer that belongs to VLAN 10. Okay, and this computer is connected to an access port of switch. The switch port is configured for VLAN 10. The computer sends normal Ethernet traffic. The computer does not need to understand VLAN tagging. So we can remember access port equal to 1 VLAN for the connected device. For example, a computer connected to VLAN 10, a CCTV connected to VLAN 40, and a printer connected to VLAN 20. Now let us understand the trunk port. Imagine we have two switches. So in switch A, we have configured VLAN 10, VLAN 20 and VLAN 30. In switch B also we configured VLAN 10, VLAN 20 and VLAN 30. Now we put to connect these two switches. Okay, now we want to connect these two switches. Do you need a separate cable to connect these switches? The answer is no. We can use one link as a trunk port, and the trunk port can carry traffic from multiple VLAN over a single physical link. But the receiving switch needs to know which VLAN each frame belongs to. Right? This is where VLAN tagging is used. The most commonly used standard is 802.1q. Please remember this line. The most commonly used standard for VLAN is 802.1q. Let's use a simple example. Imagine a railway station. Many different types of luggage are moving on one conveyor belt, or maybe airport. So many luggage will be coming on the conveyor belt. Some luggage belongs to passenger A, some belongs to passenger B, some belongs to passenger C. How do we identify the luggage? We put a label on each bag. The VLAN tag works in a similar way. The tag tells the receiving switch this frame belongs to VLAN 10, or this frame belongs to VLAN 20, or this frame belongs to VLAN 30. So the same physical cable can carry traffic from multiple VLAN. This is the major difference. Access port usually gives traffic for one VLAN typical connection like PC, printer, CCTV camera, server, and trunk port carries traffic for multiple VLAN. So typical connection will be like switch to switch, switch to firewall, switch to router, switch to wireless access point, or any other like that is anything connected with trunk port will carry multiple VLAN. That you have to remember. So access port one VLAN, trunk port multiple VLAN. So if you understand this difference, you have understood the most important building blocks of VLAN networking. So now coming back to slide 4. So in this slide, now let us see how VLAN are used in a real world network. Imagine we are designing a network for a company. At the top, we have a firewall or a layer 3 routing device. So when I say layer 3 routing device, it can be router or layer 3 switch. So currently we are talking about firewall. So below we have multiple VLAN. For example, VLAN 10 for administration, VLAN 20 for normal user. So this VLAN may be used by VLAN 10 may be used by finance department or HR department and administration users. And network example network for this is 192.168.10.0/24. VLAN 20 is for normal user. This VLAN may be used by regular employees. And example network is 192.168.20.0/24. And VLAN 30 that is used for voice. This VLAN is used for IP phones. Example network for this is 192.168.30.0/24. So keeping voice traffic in a separate VLAN allow us to apply specific quality of service policy. Please remember this line, very important. Keeping voice traffic in separate VLAN allow us to apply specific quality of service policy. For example, we can prioritize voice traffic over normal data traffic. So VLAN 40 for guest. This VLAN is used by visitor and guest user. Example network of this is 192.168.40.0/24. The guest VLAN should normally be restricted. For example, guest user can access the internet, but guest user should not be allowed to access finance server or internal application or network management system. Now, an important question, can VLAN 10 directly communicate with VLAN 20? Normally, different VLANs are separate layer 2 network. To allow communication between them, we need a layer 3 device. Okay, then it can be like router, your layer 3 switch, or a firewall. This process is called as inter VLAN routing, because we are using layer 3 device for routing. So inter VLAN is configured either in the router, or it can be in the firewall, or it can be in the layer 3 switches, where we can communicate between two different VLAN. So let us take one example. Suppose a VLAN 20 wants to access an internal server in VLAN 10. The traffic goes in layer 3 device. The device checks the routing and security policy. Then it decides, should this traffic be allowed or should it be blocked. For example, administration VLAN can access the server VLAN. Guest VLAN can access the internet. Guest VLAN cannot access the internal server VLAN. So CCTV VLAN can communicate with the video management server. This is a real power of VLAN design. So VLAN creates logical separation. The layer 3 device or firewall controls the communication between these VLAN. So a good enterprise network normally has three important layers: physical infrastructure, logical VLAN segmentation, and a routing and security policy. This type of design is commonly used in corporate office, it can be data center, it can be hospital, it can be airport, universities, government organization, or it can be a large campus network. So VLAN are not just a theoretical network concept, they are used in day-to-day real production network. So hope you might have understood the complete theory about the VLAN, and thank you very much for your time.